Well, dear my students, I am here with new topic, dual nature of radiation, that is the light also, and de Broglie. Actually, in English we pronounce it as de Broglie, but it is a French scientist, and the pronunciation is de Broglie. De Broglie is the pronunciation in the German language. But here we keep on talking or speaking as de Broglie. It is de Broglie. In last video, I have discussed or explained you the phenomena of photoelectric effect, and before that we learnt interference, diffraction, polarization. Phenomena of interference, diffraction, polarization through wave nature of radiation, light. The interference of light, diffraction of light through wave nature of radiation, or you can say light. But the phenomena of photoelectric effect proves wave nature, proves particle nature of radiation. Phenomena of interference, diffraction, polarization through wave nature. Why? Phenomena of photoelectric effect proves particle nature. So it has been accepted that both nature of radiation are true. Means the radiation has wave nature as well as particle nature. I found people much confused. Once one of the colleague, he was actually graduate in science but postgraduate in Hindi, and he always tried to discuss every field of life. It was his habit. One day he told me, asked me, sir, science people do not have many facts clear. I asked him, what do you want to say? Okay, sir, they say, sometimes they say light travel straight line, then sometimes they say light travel as a wave, and sometimes they say light has particle nature. So I said, they have all clear. It means you don't understand really the phenomena of linear propagation wave character of light क्या है, what is the wave character of light, and what is the particle nature. So I want to explain here you dear students. Yesterday I was teaching my student here in this room, and again I keep on telling them many times, I have told many times, but when I asked yesterday what is the wave character of light, they could not answer. Actually, here in every brain about wave, this thing is existing every wave travel like this. When I ask them, okay, you write equation of wave y equal to a sine 2 pi t upon t minus x upon lambda. Then which direction they will be traveling? They said along positive direction, or positive direction is the straight direction. So every wave travel straight. Then what is wave character? In case of light, I have told many times that wave character of light only is that light wave consists of oscillating electric field, magnetic field. The variation of electric field, magnetic field is the wave character. Wherever there is wave, something varies periodically with time. In case of sound wave, when wave travels through medium, particles position keep on changing periodically, and pressure variation, pressure at every point of the medium keep on changing. That is why sound wave are pressure waves. So please be very sure of this fact that wave travel straight. And then what is wave? Periodic variation of some physical quantity which take place periodically with time or distance also. In case of light wave, the electric magnetic. In case of sound wave, which are also called elastic wave, the compression, rarefaction are produced by sound wave travel state. Actually, what is this? I told you many times, it is a graphical representation. If it is sound wave, y is y, and this has distance at n time t. Okay, how does the value of y change? Here 0, it is maximum, become negative, and so on. At every place, particle medium keep on oscillating. Then what is particle nature? So when wave travel, energy is transferred. So that energy transferred is in the form of a small packet of energy. Try to understand my view. According to me, it is very clear that when a wave travel, particle, energy is transferred from one place to another. That energy transferred is in the form of a small packets of energy. Okay, it has wave character. Anyway, so I tried again to explain actually the wave character, particle character. So it has been accepted that that both nature are true, and this behavior of radiation is called dual nature of radiations. I hope you have got my point. Phenomena of interference, polarization, diffraction prove wave nature. Phenomena of photoelectric effect, which takes place when radiation like visible light, ultraviolet radiation or some higher are incident on metal surface, electrons are emitted. But that phenomena could be explained by Einstein only by taking प्लैंक क्वांटम थ्योरी के एनर्जी ट्रेवल्स, एनर्जी ऑफ रेडिएशन और एनर्जी कैरिड बाय लाइट वेव ट्रेवल इन द फॉर्म ऑफ स्मॉल पैकेट ऑफ एनर्जी एंड दैट स्मॉल पैकेट ऑफ एनर्जी फोटोन. Now when radiation has both characters, the particle as well as wave, de Broglie, a French scientist, in 1924, for your surprise, de Broglie was born in 1892 and he lived up to 1987. In 1987, he died. So de Broglie proposed that if radiation has wave character or wave attributes, attribute means in a, there is one attribute used in NCERT, property, wave property. If radiation has both character, the wave as well as particle, so nature is symmetric, so particles should have wave character. तो डी ब्रोगली वेव की बात करते हैं हम यहाँ, ये डी स्मॉल लिखते हैं वो, डी ब्रोगली, इट इज डी ब्रोगली वेव. In 1924, de Broglie proposed that if radiation or a wave has particle nature, then a moving particle must have wave properties या wave character. A moving particle must have wave character. Things are many here to discuss. I will be telling you. But if you are my student and learning from me, be very sure about the definition of wave, definition of photon picture, definition in state propagation. De Broglie, I must say de Broglie derived the wavelength of photon in terms of its wavelength, momentum. Using Planck's quantum theory and Einstein's mass energy relation as follows. कैसे भाई? डी ब्रोगली है ना, by from Planck quantum theory. From Planck quantum theory, energy of photon is given by E equal to h nu or equal to hc upon lambda, where you know h Planck constant here and c speed of light, lambda is the wavelength. So now if we assume photon is particle, if small m be the moving mass of a photon, I have already told you that photon cannot exist at rest, and photon is the only particle which travels with the speed of light. Then according to Einstein relation, energy of photon E equal to mc square. Here I told you that m is the moving mass and photon travel with speed of light. No other particle travel with that. Comparing equation 1 and 2, we get that mc square equal to hc upon lambda, or mc equal to h upon lambda. Mass into velocity momentum, but m into c equal to p, momentum of photon. And therefore lambda equal to h upon p. So he derived this equation for photon, not for any other particle. Momentum p is the property of every moving particle, product of mass and velocity. Since then he generalized this equation for every moving object as p equal to mv, and hence wavelength associated, and hence wavelength associated with moving particle is lambda equal to h upon mv. If we consider here a large mass like a ball, suppose mass is 100 gram, और यानी कि ग्राम और यानी कि 0.1 kg, and speed v is equal to say 10 meter per second. So then p is equal to 1. So lambda becomes 6.6 10 to the power minus 34 meter. That is not significant and beyond the measurement. We can't measure. But if we take particle like electron, then wavelength comes out of the, we'll be discussing here, of some wavelength comes out of the range of few angstrom, which can be measured, because we have measured the interatomic distance between the atoms of metals and other crystalline solids. So it is there, and this wavelength was verified practically by Davison Journal. And I have told in my earlier videos that electron microscope is practical application of de Broglie wave, which are called matter waves. I will be discussing meaning of this and difference between the light wave, means radiation, and matter waves. There was a question in board in class 12 chemistry. Unfortunately, no one was able to answer this question, and I read a chemistry book for this purpose. The difference was not clearly described there. So please watch this video carefully, read the book, and apply your brain to understand what is this. I am discussing furthermore about this wavelength. Thank you.